Okay, I just wanted to make a quick video going over a couple of the trigonometric verifications from your homework, just so you guys could see a few more of them worked out. And then I know you have more to do this week that you're going to turn in on Monday or Sunday night, so I figured this might be beneficial. First off, number 76, the ones towards the end of your homework were the ones that a lot of people just left blank or said, I'm not sure what to do here. So these are the last two from your homework this week, 76 and 88. For 76, and I know you all have it written down, sine x cotangent x divided by cosine x tan x should equal cotangent x. And as I said before in some of the other videos we've done, ultimately the idea here is to develop your algebraic thinking to the point where you can just kind of see what trick you should actually use. In this case, we have a whole lot of trig functions. We ultimately want to turn it into one trig function. And we want to turn it into one trig function that isn't a fraction. So somehow we have to turn this really big fraction into just one thing. One of the tricks we can use is simplify that fraction out right there to put it in lowest terms, for lack of a better way of saying it. And a lot of times the biggest issue that people have is having a whole lot of different trig functions and tangents and cotangents and all that, which throws everybody off. So one of the first things you can do is write everything in terms of sine and cosine, because we're used to those. So if I rewrite this, we're just going to focus on the left, like I've said before. So we get sine x cotangent x is by definition cosine x over sine x all over cosine x times tan x. Tan by definition is sine x over cosine x. And now from there, simplify this. All of these things are multiplied together on top and bottom. And I'm assuming that you guys have worked with fractions enough that you understand if these are multiplied and there's a fraction in the numerator, then the denominator here gets sent to the bottom and multiplied. By the same token, if there's a fraction in the denominator here gets sent to the top and multiplied. So if we kind of rewrite everything on the top, that sine x stays there, that cosine x stays there, and then the cosine x from the bottom here gets sent up top. On the bottom, the cosine x stays there, the sine x stays there, and then the sine x from the top, from here, gets sent to the bottom. Now it's just a fraction, put it in lowest terms. Let's see, the sine on top cancels the sine on bottom, cosine on top cancels cosine on bottom. All that's left is cosine x over sine x, which is by definition cotangent x. And we're done. And that's it. And again, the point, it's incredibly straightforward and direct. Do not think you somehow have to do 43 incredibly complex algebraic steps to solve these. You're verifying things that are true, which means they have to work out nicely for you. They're designed that way. Use your definitions, put it in terms of sine and cosine, cancel like terms, and you're done. Okay, so for the other one, which looks maybe more complicated, number 88. Tan x over secant x minus 1 equals secant x plus 1 over tan x. And again, as far as it goes, the kind of algebraic thinking that we ultimately want to develop here, well, let's see. That's a fraction with one term on top and two terms on bottom. That's a fraction with two terms on top and one term on bottom. If nothing else, I have to find a way to make the two terms in this denominator, the two terms equal to the one term in that denominator. And the standard trick that we have been using, especially when you have something like secant x minus 1, sine x minus cosine x, tan x plus 1, things like that. When you have a plus 1 or a minus 1 a lot of times, multiply by the conjugate. That will turn into a difference of squares, which given our trig identities is very beneficial for us. So in this case, again, we're only going to work on the left. I'm going to multiply the top and bottom by the conjugate. So we get tan x times secant x plus 1. Remember, the conjugate just means flip the sign in between. All over secant x minus 1 times secant x plus 1. And on the top, don't multiply that out, distribute or anything, just leave it like it is. If only because our answer needs a secant x plus 1, which now I have there. So don't distribute out and make it all jumbled together, because odds are you're going to have to pull it apart again. But now, on the top, we get tan x times secant x plus 1. On the bottom, secant x minus 1 times secant x plus 1, that's a difference of squares. It's secant squared x minus 1. And now, in the back of your book, a lot of these Pythagorean identities are listed. If you're using an e-book, there is no back cover of the book to look at. But if you look in this section, 5.1, it lists out all these Pythagorean identities solved in different ways. And in this case, secant squared minus 1 is equal to tan squared. So I can rewrite this as tan x times secant x plus 1 all over tan squared x. And now, do what we did over there, reduce it. There's a tan x on top and a tan squared x on bottom. This tan x cancels with one of those tan x's. And then all that's left is secant x plus 1 on top, tan x on bottom, and that's exactly what I wanted, and I'm done. And again, I would stress, as far as these go, this one took like 2 steps, this one took like 3 steps. So if you think you somehow need to do like 14 steps to solve these out, you can do it that way and it will work. As long as the algebra you do is correct, you can get the answer. Generally speaking, there are easier, shorter ways to go. And that's kind of the ultimate goal here. But you learn that by developing the algebraic thinking, by just practicing and getting to the point where you can say, oh, okay, I'm just going to rewrite all these in terms of sine and cosine and then reduce it and I'm done. Oh, I have a secant x minus 1, multiply by the conjugate, use a Pythagorean identity, and then I'm done. I think that comes with practice, which is why I gave you so many to do. I hope this helps, and like I said, just keep on working on the ones you're doing this week that are due on Sunday night.